So hi everybody. In today's video, I'm going to go over how to do optimal pricing calculations or optimizations. So basically, this happens a lot where you want to do optimal pricing, and let's say you're selling some product, you are free to choose the price. What should the price be? That's the fundamental question. And what I'm going to show you today is how to calculate that optimal price using some kind of framework to do it. There's different frameworks to do this. Here, I'm just going to illustrate one in Excel because it's pretty simple. Obviously, you could do this in Python or R or whatever. The calculations are not like too involved here. There are more advanced versions of this depending on the type of problem you're doing. But in this case, I'm just going to illustrate the core concept. So this is sort of the end result where you end up with this optimality curve on profit. And you can see that there's like a maximum around here that basically indicates what the optimal price should be. If you decrease the price or increase the price, your profit will be expected to drop. And so there's an optimality point here that would basically determine the price essentially. And your whatever item you're selling is going to have a price that you choose. At that price, you may sell a certain number of those units. If your price is too high, you're going to sell fewer units. If your price is too low, you're going to sell more units. So, if your price is too expensive and you sell fewer units, that's actually not good because if you sell too few units, you're not going to make that much money, even though they're expensive. If your price is too low, you may sell more units, but you're not going to make that much money per unit. And so you may not make that much money in that scenario either. There's a sweet spot in the middle that's illustrated by this graph that we're going to construct. And it's basically, this is how you mesh together the quantity demanded, the demand curve, as it's called, with the pricing and the quantity sold and everything, and you kind of construct this curve and it tells you what the optimal price should be. So let me walk you guys through how we would go about doing this. So the data set we're going to use here is this avocado prices data set that I found on Kaggle. It's just historical data on avocado prices and the corresponding sales volume sold in multiple US markets. We're going to cut the data down to a specific segment to simplify things, but that's basically what it is. Um, so you're going to have the average price of the avocado sold, the total volume of how many units were sold, and the date range and all that kind of other stuff. So you could just download this. I'll put this in the description box and all that kind of stuff. Let me tab over to the data now. So this is what the data looks like. So you have your price over a date range, your price for a certain day, average price, how many units were sold. You have these other columns which are like the different PLU numbers of specific avocados that were sold. We're not going to get too much into that. We're just going to cut this data down to something simple that we can illustrate the method of optimal pricing. So I'm just going to choose conventional type of avocados, and in region, I'm just going to grab the total US. And we're just going to look at this data set on average price and total volume from the year 2015 to 2018. So I'm going to grab these two columns. I'm just going to come over here and paste them. And what I want to do from here is just make, sampled data. What I want to do here is construct a little scatter plot to show what the demand curve looks like. So this is actually the demand curve, which shows us basically as the price, which is on the x-axis here. So if I do here, this is the price. As the price increases from left to right, the quantity demanded, which is on the y-axis, or the units sold, so the demand, decreases. So in other words, as things get more expensive, as you go more expensive in price, so from $1 to $1.20 to $1.40, $1.60, the number of units you sell decreases because people, if things are more expensive, people are going to buy less of it, right? In general, in aggregate. if things are cheaper, people are going to buy more of it, and that's what you're seeing in this curve. And so once you have the demand curve from a historical data set where you sold your item at different price points and you have different corresponding volumes of units sold at those different price points, this is a key ingredient to construct the demand curve for the optimal pricing to happen, basically. Um, There's another way to do this where you have like the probability of a unit sold at a given price point if you have something like quote data. Um, so maybe like you quoted an item and it may or may not be purchased. If you have data like that, you can construct a similar sort of model. I will show that probably in a separate video, but it's the same principle that's at play. But here, we're going to do it this way. So what you would do from here is we'd want to add a trend line, and I'm just going to do linear. I think if you look at these other ones, they're not too different, but linear. Let's get the equation on the screen there. So basically, the linear model, there's some noise around this, and if you cut the data down better, maybe to more specific market and a specific PLU number, you would get tighter data. But it doesn't really matter. What the demand curve dotted line tells us is just simply that on average, in the aggregate, in the presence of noise and everything, as the price grows, the demand drops. As the price decreases, the demand increases, or the units sold increases. So this is a key component of what's needed to do the optimal pricing. So let's hop over and do that right now. So if we come over here, what we're going to do, so let's call this optimal pricing. Let's say, we have our product. Our product is avocado, right? And let's say it's a single avocado. How much is the avocado's price? Let's just put in some dummy numbers here. So let's say we're selling it for $1.40. Okay. And let's just say, maybe it costs us to procure this avocado, right? To work with the vendors and the shippers and wherever it's coming from to pay for the logistics and all the storage and everything to bring it here. Let's just say per avocado it costs like 80 cents. So your profit on a sale of one of these guys is just going to be the difference of the price and the cost, right? So you make 60 cents on one of these avocado sales, right? Now, at this price point, we actually have the demand curve, which tells us expected units sold at a specific price point. So if we go back over here and we grab this regression model, so let's just paste that there. Yeah, it didn't copy. Let me copy that. Okay. So if I paste this here, I just want the text. There we go. So the X variable is our price, and this gives us our demand. So I could rewrite this a little bit. So just say, this is times price, and this is the intercept there. So, and then this is our units sold. So this is our demand curve here, right? So at this price point, how many units do we expect to sell? Well, we just plug into the formula here. So I'm going to grab this again. Let me grab that and treat it like a proper equation. So price is actually this $1.40. So we expect to sell 22 million avocados total US worldwide. What if we shrink the price now to, let's say, $1.10? That number increases because now it's cheaper. We expect more sales. If we decrease it to, say, 90 cents, we expect to sell even more. But you notice that as we're decreasing the price, the profit we're making is shrinking because the difference between the price and the cost is decreasing. What if I make this like $2, which is pretty expensive? then I sell way fewer units and my profit is higher, but I'm selling way fewer units. So there's a sweet spot in the middle, and that's what we're going to try to find. So this is the total expected units that we'll sell in aggregate, and then total profit on all units sold would be the amount of avocados we expect to sell times the profit we make on each of those sales. So that gives us this number here. So we can see now, like, let's make this avocado super cheap, 90 cents. We make about 3.2 million on that. Now let's make it really expensive. Let's make it $2.50. We don't make, well, why did this go blank? Let me see. I think it goes negative. Well, it goes to zero actually. So if we, so 2.1, 2.2, yeah, it starts to shrink. Yeah, 2.4. It just keeps shrinking. So 2.35. Yeah, so as we make the price higher and higher and higher, the demand curve starts to go to zero. The amount of units we sell starts to shrink. So there's a sweet spot somewhere in the middle where our profit is actually like a bigger number. So let's go ahead and compute this out and try to find the maximum. So all we need to do is basically repeatedly calculate the total profit at different prices sold. And this is where we can use a nice sort of feature of Excel, the what if analysis. So I'll kind of show you how to do that here. But basically, all we're going to do is calculate the total profit repeatedly for different prices sold, and then we can kind of go from there. So the way you could do this is, there's lots of ways to do it. Obviously, you don't have to use the what if thing that I'm going to show you. Dude, I'm just going to do it because I like it, and it's interesting. It's good to know. So let's say we have, the current price, which is the $1.40 that we have sitting in this little calculator thing up here. So let's go like this. The current price, well, profit. We have the current price, and then we have the profit here, which would be just this 13, right? So at the $1.40, so I'll just put $1.40 here. At $1.40, we've got about 13.2 million expect in total profit, right? So now what we're going to do actually is create a range of prices. So let's go in units of 10 cents. So we're going to start at 80 cents and add 10 cents. And we're going to go all the way to, let's say, I don't know, 2.5. So let's do that. And let's make this all dollars. Okay. So now we're going to do this what if analysis, we're going to calculate the range of total profit that we'd get here. So this is like the current row used by the data table function thing, right? So let me show you. What you do is you highlight all this, right? So remember, this cell contains the formula, right? This links to this, which then itself links to all of these cells, right? So this is going to get repeatedly calculated, as you'll see. So you highlight the range, and then what you do is you go over to data, what if, data table, and then what you want to do is you want to say, okay, I have a table here that I want to fill in, and the variable here is in the column. This is the column, so I want to use column. Column is what I want to input, and this column is the price point, so I want to say use that there. So take all these values in this column and repeatedly swap them in here in this cell for price, and therefore repeatedly calculate what all these total profit cells should come out to be. So if I do that and click OK, it fills it in for me. And you can see now, like from here to here, this is basically the range that I want to calculate. And you can see that for lower prices, I make less profit in the millions, right? 3 million, 6 million if my price stays at 90 cents or $1. But you can see that at the high end too, if I'm at 230, 240, 250, I'm also selling, in the 3 to 4 to 5 to 6 million in profit, and it's somewhere in the middle. I reached this 14 million in change, which is my maximum. This is my sweet spot. So to see this in like more of a graph, let's just insert a line chart over here. Um, I could do a scatter, whatever. Scatter sometimes nicer. So here you can clearly see it. As you vary the price, your total expected product has a bell-shaped curve, and the optimal point is somewhere right here in the middle. It looks to be $1.60 to $1.70. You kind of have, the optimal point is somewhere right in the middle of that. And if I take this and I put maybe 1.65, let's say. So yeah, that number is actually higher. So the number we want is actually in between. It's 1.65. It looks to be. So that's basically how we do this. So let me just add the axes here so we're not confused about anything. This is now expected total profit in dollars, and the x. So that's the y-axis. The x-axis here is the price we are setting um, avocado at. Right. So again, if you want to maximize your profit, which is generally what you're trying to do, you want to, in this case, pick it to be $1.60 to $1.70 per unit, and that will, in expectation or on average, guarantee that you would make the most total profit. Um, so that's basically the method in a nutshell. You want to basically construct here this um, profit optimality curve, and once you have this, you just find the maximum, and that gives you your total price. I mean, sorry, it gives you your optimal price, right? Whatever price is at the maximum. You go to the maximum, then you drop down, and whatever that number is, that's your optimum. We kind of figured out here for the data table that it's somewhere between $1.60 and $1.70. You reach your maximum total profit. Remember, this is our price range, and this is our total profit range. So our maximum is somewhere here. So that's pretty much it. I just wanted to share a quick video here on sort of the framework of how you can do price optimization, provided that you know your item's cost to make it, and you have a data set that contains your item sales, how much you sold of the item at different price points, so that you can construct the demand curve. So the demand curve construction is a prerequisite to doing this. Um, but if you have that data, and if you can make the demand curve, and you know the cost, and you can construct this and come up with your optimality curve. So yeah, that's pretty much it. I've used this quite a bit in my actual work in different ways, different manifestations of this. But this core principle applied, in creative ways can be very powerful, at your job where you're trying to add value. Maybe there's some price optimization projects. You want to maybe start thinking about them with this in mind, and it might help you move the needle to arrive at something more actionable and useful. Because a calculation like this can even be done dynamically. Maybe it's something that updates in real time. Maybe it's something that is just refreshed every quarter or something like that too. But it can be applied in many different ways. So hopefully this was useful. Hopefully, you guys get to use it in creative ways. Let me know if there's anything else you want to see in the comments that I can cover on this. But yeah, till next time, I'll see you guys.